We're going to do section 5.3 in 173 class, and we're going to work on substitution. So here we're looking at what can we do. So I'm going to let you, what I'm looking for is something that kind of makes sense here. And secant times tangent reminds me of the derivative of secant x. And if it doesn't remind you of something, you need to familiarize yourself with the table of derivatives, but that's what this is. So I see a secant here, so I'm going to let u be secant of negative 10x. So then if I take the derivative of this side, I get derivative of secant of something is secant of the something times the tangent of the something. And then the chain rule says I have to take the derivative of the inside, and the derivative of negative 10x is negative 10. And that would be du dx, so I have to I'm putting the dx there. Okay? Well, all of this pretty much looks like this other than the minus 10x, but no, that's right. So I'm going to do substitute here, and so I'm going to do it. The book kind of does it slightly different than the way I teach it. So I'm going to write down here, we've got the integral of negative 9, which we could pull out. And then there'd be secant negative 10x, tangent negative 10x, and that would be over secant squared of negative 10x, but that's what u is, so it'd be u squared, and then du would be negative 10 secant negative 10x, tangent negative 10x. Oh, but that would all end up under the du. Not thinking here real clear. Let's get this straight here. That's du over that stuff. Negative 10 secant negative 10x, tangent negative 10x. When I solve for dx that I'm going to replace, this is all going to go under du. And these cancel, and I end up with a negative 10 coming out. And so we get the negatives would cancel. They're going to have it in the 9/10 or 0.99 inside, and 1 over u squared du. So now this is a fairly basic integral. That's going to be, in terms of u, this is u to the minus 2. So if you take the antiderivative of that, that would be u to add 1 to the power, minus 1, and divide by the new power, the reverse of the power derivative power rule. And it's going to be times 9/10, and they're going to be a plus c. U to the minus 1 means I can put it back in the denominator, so this is going to turn out to be negative 9/10, because of that negative, and u to the minus 1 is 1 over u which we said was secant negative 10x. So the derivative of this is this mess. The antiderivative of this is this. Okay. This one. Now, I know that substitution works on this because I remember that the derivative of cotangent x is negative cosecant squared x. Now, the 2 is going to make it a little different, but not much. And so I see the derivative of cotangent sitting here. So I'm going to let u be the cotangent of 2x. So then du would be the derivative of that, which is negative cosecant squared of 2x times the derivative of the inside, which would be a 2. So I'm going to make some room here and move the minus over and put the 2 there. Dx. And when I replace the dx, I'm going to have du over this. So this would become the antiderivative. I would pull the minus 4 out so it doesn't hinder me there. I'd write the cosecant squared of 2x and e to the u, and du, a dx is du over negative 2 cosecant squared 2x. And the cosecant squared of 2x cancels. The negative 2 would go into the negative 4 and make plus 2. I could put it back in. That's what they're kind of asking me to do. E to the u du. So 2 would pull out. Antiderivative of e to u is e to the u. So my answer to this is going to be, this will be 2e to the u. And then we put this back in for u. So our final answer is going to be 2e to the cotangent 2x, that's the u, plus c. And no minus. Yeah. Okay, number 3. Looking at this, I see that it's a good candidate for substitution because the derivative of t to the third minus 4 will have a t squared. Du would be 3t squared. Derivative of negative 4 is nothing. dt. So this would turn into the antiderivative of t squared u squared, and dt would be du over 3t squared. And fortunately, the t squareds cancel, so I have something that's all in terms of u, and I can integrate it. The 3 would come out as a 1/3, and the antiderivative of u to the 2, you add 1 to the power, so it's u to the 3 over 3 plus c. But now we need to go back to t's. So it's 1/3 and a 3 in the bottom, that'd be 1/9. u to u, which was t cubed minus 4 to the third plus c. Okay, and this one, well, if I'm trying to find the antiderivative of this, I see right away that if I let u be just the x squared, the derivative would be, if I let u be x squared, the derivative would be 2x dx, and the 2x would go underneath when I solve for dx, and that x would cancel. So I'd get the 9 would pull out. It's a constant. The x doesn't. Cosine of u, and then it's dx, but dx is du over 2x, and the x's would cancel. The 2 comes out in the denominator because it's in the denominator, so this would be 9 halves. Antiderivative of cosine, derivative of sine is cosine, so this would be sine of u, but going back, that would be x squared, because u was x squared, plus c. 4. So ln is kind of the exception to the rule. Normally we let u be something there, but here we're going to let it be lnz. And hopefully you remember that the derivative of ln is 1 over whatever it is. So this du would be 1 over z dz. And if then I need to replace dz, so I'd have to multiply both sides by z to get the z off of this side, and so this would become the antiderivative. Ln z is u, so this would be u to the 4th over z, and dz would be z times du. And since it's a mix of variables, I can't do it until I clean that up, but fortunately the z's cancel, and so I'm just integrating u to the 4th du, which is a fairly simple. You add 1 to the 4, makes u to the 5th over 5 plus c, but u was ln z, so this is ln of z to the 5th over 5 plus c. And number 6. I think I would let u, I do not like addition in the denominator, and I know if I took the derivative of this, the 3 would disappear. So I'm going to let u not be just 3x or e to the 3x, but be 3 plus e to the 3x. So that du would equal derivative of 3 is 0, and derivative of e to the 3x, well, that's e to the 3x times the derivative of 3x, which is 3. So if I come to here, this would change to this. We don't have anything, so I'm just going to leave it, e to the 3x. This is u, and dx is du divided by 3e to the 3x. The e to the 3x's cancel. The 3 comes out as a 1/3. So I got 1/3 the antiderivative of 1 over u du. That's u to the minus 1, but we can't use the power rule on minus 1. Every other power we could. But 1 over u's antiderivative is ln, natural log. So it's 1/3 natural log of u plus c. But u is this. So we're going to write 1/3 ln of 3 plus e to the 3x. And it turns out I wouldn't need the absolute value because e to some power is always positive, and adding 3 to it would just make it more positive, so this is always positive, so don't need the absolute value, but you can put them in. Doesn't make it wrong, but it's not necessary. Okay, that was the problems I assigned in 5.3 on substitution.